Hello, in this video I'm going to talk about trigonometric functions of non-acute angles. Now you probably learned that an acute angle is any angle that is between 0 and 90 degrees. Now the way in which that we can start is by considering the following angle measure, 1200 degrees. Okay, well 1200 degrees is quite large in the sense that it's not within 0, 360. Now remember that we can rewrite an angle measure, call it theta, and we can just rewrite it as 360 degrees multiplied by n plus theta prime. Now in this case, theta prime is the coterminal angle. However, now we want to also find what is called the reference angle. So to kind of give you an idea of what do we mean by reference angle, well, say for example that we have a angle measure and it happens to terminate in the first quadrant. Now in this case we have that the angle measure theta, it's going to be equal to this angle measure that we'll just go ahead and call theta prime, and we'll just say that for this, the angle relative to the x-axis in this case will be the reference angle. So we'll just say theta. So that means that if you have 30 degrees, 45, 60, 75, even 15, that's the reference angle because you're in quadrant 1. So in this case, it's almost like there's nothing to do. So then, well, what gets interesting is what if the angle that is in question happened to terminate in the second quadrant? So we'll just write it over here. Now, whenever we're looking for reference angles, since I went ahead and said relative to the x-axis in the first quadrant, that's how we're going to actually refer it. So say that you have a ray that terminates in the second quadrant. So what that means is that this angle measure, it not only terminates in quadrant 2, but now we want to see what the reference angle happens to be. So here we're going to say that this angle measure right here is going to be theta, and we'll call it theta prime. But this one, we'll say that one's theta, just theta. Now the question becomes, how do you figure out what theta is equal to? Now this is where it might get a little strange because of the notation and whatnot that I chose. But for this, say that you wanted to find the angle measure theta prime. Well, one way to do that is to think of it like this. You want to find the angle, how much it is relative to the x-axis. In this case, this was 0, so there was nothing to do. So what we can do here is just say, well, theta prime is found by taking 180 and subtracting your theta, because you can see that both of these two angle measures will add up to the straight angle, or 180 degrees. So that's the way that we can find this reference angle, which means that you can technically project it into the first quadrant, because if this was 150, well, 180 minus 150 is 30, meaning that 30 is over here, but it's the same over here too. So it's kind of very similar. But if you think about like projections, then it's the same thing. Now the other possibility is what happens if the angle measure terminates in quadrant 3. Okay, well, if it terminates in quadrant 3, now you want to do it the exact same way. Basically, you have that this is theta, but this angle right here is theta prime. So this is all relative to the x-axis. So in this case, we can say that this is 180. Okay, so the way that we can find our theta prime, is that we're going to take theta. Okay, so we're going to take theta and we're going to subtract 180 degrees, and that's going to be equal to our theta prime. So in this case, we have that the reference angle, it's over 180, so that means that you just have to subtract it out in order to figure out what it is. So like if this was 210, then you do 210 minus 180, which is 30, which again, you can project it into the first quadrant or in standard position as mentioned before. So this is quadrant 3. And again, reference angles are basically just relative to the x-axis. So another that possibility that you might have is that what if, for example, the angle measured terminated in quadrant 4? Okay, well, we're going to say that this terminated in quadrant 4, and that means that the angle, it went from 0 all the way over here. Okay, so that's theta, and this angle that's in between here is theta prime. Now, one thing that we need to mark on here is that this is 360 right here. So the question becomes, how do you find theta? How do you find theta prime? So in this case, you're just going to take 180, or not 180, but 360, and you're going to subtract theta. Now that equals to theta prime. Okay, so that means that, yeah, if you had that this was 320 degrees, you would subtract that from 360 and you get 40 degrees as the reference angle. Now, so the key is that you have to remember that a reference angle is relative relative to the x-axis. And it helps to actually draw it in the x and y plane to figure out what quadrant it terminates in. Let me just scroll up a little. Okay, so you have basically 4 possibilities. The only issue that I have when thinking of this topic is really just like what happens if the angle is too big. So then that means that we're going to have to do like first a few steps before we even get to the reference angle, and that's where it gets a little tricky. So why don't we just return back to the original angle measure that I had. So I had 1200 degrees, and we can put this as theta, for instance. Now, unfortunately, we're going to have to figure out like what is the coterminal angle to this. So we have that 1200 degrees, and we can tell that that's bigger than 360, so we know that we have to subtract 360. So when we subtract 360, okay, so this is going to give us 0, let's see, that's 1, that's a 4, and then that's 840. Okay, so 840 degrees is still bigger than 360, so we'll just subtract it again, so 360, and that's going to be 0, let's see, 7, okay, so that's going to be, okay, so that's going to be 8, and that's going to be 4. Okay, that's why I was like taking a little pause, because it looks like I have to do it again. So minus 360, and then that's going to be 120. Okay, so now we have that basically this angle measure, 1200, is coterminal to 120. Now, consider this. How many times did you subtract 360? You subtracted it once, twice, 3 times. So what that means is that basically what happened is that in the x and y plane, or in our coordinate axes, you went around, or the angle measure went around like 3 different times. So you have 1, 2, 3, and then you had that it stopped at 120. So in this case, you have that this is kind of like that. Now, you don't technically need to draw it like this if you don't want to. Like, you could just say, if you know that it's already 3 times and then plus 120, then you can just put the ray and indicate 120. Okay, so it seems that it terminated in quadrant 2. And it seems that we have that this is relative to the x-axis 180. So what we're going to do is we're going to take that theta prime is equal to 180 minus 120, which is equal to 60 degrees. So that tells you that 60 degrees is the reference angle. So imagine if you were trying to find cosine of 120, cosine of 1200 degrees. That's pretty tough because basically you have that cosine of 1200. You would have had to figure out what's the coterminal angle, which means that you would have found that that's cosine of 120. Furthermore, you would then figure out like what's the reference angle. So once you find the reference angle, then you can say that this is easily cosine of 60 degrees. But where did cosine terminate? It terminated in the second quadrant, which accordingly we mentioned that, we mentioned that all students take calculus, which basically means that this wouldn't be positive, but it would be negative, which then means furthermore that this would be negative 1/2. So if you're wondering why did I evaluate a trigonometric function of a very large angle measure, well, it's not only because you're going to have questions like this on your exam, but it's a lot that comes up in your homework where they ask you to find tangent, cosine, cosecant, and so on. So it's going to take some practice on how to find, the trigonometric function value of a non-acute angle when you have many steps that go from the beginning to the end. Now, if you want to find like a really fast way to figure out like how do you know how many times to subtract 360, remember you just you divide 360 into 1200 and then you round down, and then from there it'll tell you kind of like what number of times you need to subtract 360, if you want to do it that way. So like for example, we said 1200 and you would divide by 360 and you get that it's 3.333, so you just subtract 3 times, so 1200 minus 3 times 360, and then that's where you get 120, and then from there you can work out the rest. Okay, so this means that we can try an example. So if we try an example, like let's say that we want to find the reference angle. Okay, so in this one, let's go ahead and say that we have 315 degrees, and in part B, we'll just say that we have 1080. Okay, now in each of these, there's going to be methods of which that we can do this, of which part A is actually very easy, because part A just tells you that you just have to draw an angle measure that is 315 degrees. So 315, the thing is that you're going to have to get kind of good at kind of knowing where things are by saying, if you know that this is 0, 90, 180, and 270, and then you know that 360 is right here, then you'll do that. In some cases, like if you took trigonometry like in high school, most likely you had to use like a protractor or some type of measuring device to be able to know what is 315 degrees. But if you kind of just think about it in terms of the quadrants, then it makes more sense that 315 has to be between 270 and 360. So I'm going to draw it like this. Okay, so I know that 315 terminated in the I know that it terminated in the fourth quadrant, so I know that theta is equal to 315 degrees. Now, let's just scroll up a little bit. Now, the thing is that I need to figure out what this angle is right there. So that angle, remember, is theta prime. Now, the way that we find that is by saying relative to 360, you're just going to take that theta prime is equal to 360 minus 315. Now, notice that that gives you 45 degrees. So the reference angle is 45 degrees, and that's it. So in the case that you wanted to find tangent of 315, you would basically say that it's -1. Why? Because you find the angle, or you find the location. Then from there, you find the reference angle. Once you know the reference angle, then you know that tangent 315 is equal to tangent 45. But then you have to account for the sign. So all students take calculus. So in that case, it would be negative tangent 45. And then that would be tangent of, well, it would be -1 after that. Okay, so let's go ahead and try another example where well, technically we already have another example with part B. So that's going to be that theta is 1080. So this is very similar to that question where we had 1200 degrees. And for all we know, it might be, actually it's not 1080 now that I'm looking at my notes. It's actually 350, it's actually bigger than that. Yeah, 1080 is like a reference for me. It's actually 1305. Okay, so theta is 1305. Yeah, so if we take that theta is 1305, all that we need to do is rewrite it in the manner of 360 times n plus some unknown measure, which unfortunately, yeah, you use that notation. That's where it can kind of get confusing. But we don't need to think of it like that. So let's take 1305 and divide that by 360. That tells me that I need to round down to 3, so that means that you're going to take 1305 minus 3 times 360, and it's 225. Okay, so we basically are figuring out that 1305 is equal to 360 degrees times 3 plus 225 degrees. So this is just telling me that the coterminal angle is 225. So in that case, it's more or less kind of like the same thing, because you're figuring out like what is the coterminal angle, then you're figuring out like what is the reference angle. Sometimes the reference angle and the coterminal are the same, but that's only when it lands in the fourth quadrant. Now check this out. 225 lies over here. Again, that goes with me knowing that that's 0, that's 90, that's 180, and that's 270. And then we have that's going to be our 225. Now, in this example, I didn't go, around 3 times because, I mean, for me, I know that it went around 3 times and then it added 225. So if you want to indicate the spiral, you can if you want to. So once you do that, all that we need to do from here is just take the 225 now. So 225 minus 180, this is going to equal to 45 degrees. So basically this tells me similar that the reference angle is 45 degrees. Note that, these two are the same reference angle, but how would you distinguish their tangent functions, for instance? Like you have that tangent of 1305, it would be equal to tangent of 45, but that would be it because basically you have all students take calculus, meaning that it would be positive tangent 45. But then if you have tangent of, um, let me see, what was that first one? 315. You would have that tangent of 315 would be negative tangent of 45. And these are kind of some questions that you should ask yourself or try to see, like, how does that work? Because this, again, are questions that you might run into. Okay, so um, the next thing that we can look at, for example, is, well, let me go ahead and put one that you should try on your own. Go ahead and try to find the reference angle of 870 degrees. Furthermore, that's going to be your theta. Furthermore, go ahead and see if you can find cosecant of 870 degrees and then see what you get. Now, the thing of which that we're gonna look at, for example, is special angles. Now, when we talk about the special angles, basically we're talking about the 30, 45, 60, which, I mean, we kind of did that just now. Okay, so let's say that, for example, um, um, that we try um, we try the following angle. So theta equals to, let's do 210 degrees. And then for B, let's do 300. We'll do 330 degrees. Okay, now, if we go ahead and we try to figure out like these reference angles, we can go ahead and figure those out by just graphing them in the x and y plane. So for part A, 210, we again know that that terminates in the third quadrant. So we'll just do that. And we're just going to draw our angle. Okay, now we know that that's 180, but we also know that this is 210. Okay, if we go ahead and redraw part B, Well, similarly, I don't like that. Okay, so similarly, if we go ahead and we do 330, it's the same. Now, you might be wondering, did I just ask the same question? Not really, because we have that if we draw each one respectively, you'll notice that they terminate in two different quadrants. So that's how I know that I didn't technically ask the same thing in this question. So this is going to be 330. And remark the difference. This is 360. Okay, so we'll go ahead and find the reference angle of this one. So the reference angle to this one is taking 210 because it terminated in quadrant 2, and we subtract 180, and that gives us 30 degrees. So the angle is 30 degrees as the reference, but check this out. Over here it terminated in quadrant 4, so that means that you take 360 and you subtract 330, and that gives you 30 degrees. So for here, we found that the reference angle happened to be 30 degrees in both situations. Back over before, we did that the angle was 45 degrees, so that's what I mean by we kind of already done this before. So, for example, if you want to go ahead and try looking at the angle 240, then you can, and then for this one, maybe look at secant of 240 and see what you get. Okay, now it looks that we can go ahead and say, for example, that we can evaluate these trigonometric functions. So let's go ahead and look at how we can evaluate some of these. Okay, so let's say that we have sine of negative 150. Let's say that we have a cotangent of, let's see, yeah, this is 780. Let me scroll up. Okay, no, that was 870. So, okay, so from here, we know that we can basically evaluate these respectively. So with part A, let's go ahead and just work this out. Whether you want to draw it or not, we'll see first. So negative 150 is less than 0, so we know that we have to add 360 to figure out what that's coterminal to first. So that's going to be, actually that's 210, isn't it? Yeah, so that's 210. And from there, well, we already know that basically 210 terminates in the second quadrant. So that's going to be, and you don't have to draw these all the time. So you have that 210 goes like that, and we know that basically that 210 is equal to, or not equal, right? Yeah, minus 180, which that's going to equal to 30 degrees. So what that means is that this is equal to sine of 210, but this is also equal to sine of 30 degrees. Now, from here, you're just going to make it negative. Why? Well, it's because you have that all students take calculus, so that means that it's going to be negative. Now, here's where things get a little interesting. The question becomes, how do I know what sine of 30 is? Okay, now sine of 30 is basically determined by those trig triangles that you looked at. So like this is 1 root 3 and this is 2. And what are those angle measures? Well, those angle measures are this one is 60 and this one is 30. Now remember that basically sine is going to be opposite over hypotenuse. So from there, you're basically just saying, well, opposite of 30 is 1 and the hypotenuse is 2. So what that means is that sine of negative 30, or whatever you want to say, okay, so you have negative sine of 30 is equal to negative 1/2. So the answer is negative 1/2, because remember that you have that this was equal to sine of negative 150. So you have that that would be that, yeah, sine of negative 150 is equal to negative 1/2. Okay, now we have to do the same thing with cotangent of 780. Now, cotangent of 780, we're going to have to go through the process of figuring out, yeah, like what's the coterminal angle to 780. Now, 780, if we just subtract 360 times 2, well, that's going to give us 60 degrees, I believe. Let's see. Well, we can just do 780 minus 360, why not? And minus 360 again. Yeah, okay, so that's 60 degrees. Okay, so finally we get a different angle. And that's telling me that I went around 2 times and just added 60 degrees. So if you want to do something like this, you can, where you draw it. So you don't have to draw the spiral if you don't want to. So 60 degrees, we'll just do it like that. Okay, so theta. Okay, so remember how we did this. We find the coterminal angle, and the coterminal angle in this case is 60 degrees. But that means that pretty much that is the reference angle. So what that's telling me is that you're finding cotangent of 780 is equal to cotangent of 60. Do you have to account for the signs? Of course, but in this case, there's nothing to do because it's in the first quadrant and they're all positive. So now you go back to cotangent of 60. Well, cotangent of 60 is adjacent over opposite. So according to the triangle that I'm looking at right here, that's going to be adjacent over opposite, which is 1 over root 3. So that's going to be 1 over root 3, which is the same thing as root 3 over 3. So the answer is root 3 over 3 for 780. Now, what you can probably do is try the following. Try to find the cosecant of negative 225 degrees and see like what that gives you. Now, note that, for example, that you can evaluate these if you wanted to. Like, for example, if you do cosine of 780, interestingly enough, because the angle that was the coterminal and was also equal to the reference, it was 60, notice that it's just going to give you a half. But then notice that if you do the same angle measure, that it gives you approximations, which, I mean, is okay, but, if you want exact values, then you're going to have to use the triangle method. Now, we'll go ahead and look at, for example, let's say that you have, okay, so for this next example, it's really just evaluating things, so there's not really anything to do too much. So you have sine squared of 45 degrees plus 3 times cosine squared of 225 degrees. Not 225, 135. And then this is minus minus 2 tangent of this one is 225 degrees. Okay, now it does make sense that you can plug this into your calculator and then just be done with it, but let's just go ahead and work this out in a way that, uses reference angles. Now, what I need to do basically is probably just refer to the right triangle where you have 1, 1, root 2, and then you have that this is 45 degrees, because I can tell that this is going to be 45, and then you'll see the rest. So I already know that the reference angle for 45 degrees is 45 degrees, but I need to find 135 and 225. Now, 135 is actually in the second quadrant, so that's going to be like that. But if we go ahead and we go through the process of finding, the reference angle, we'll have that that's 135, but this is going to be 45. Now, if we look at 225, similarly, I wonder if it's okay if I just do this. Just draw a line right here, and just put another, maybe like another color, where I have like that. And I'll just put that that's going to be, oh wait, this is the wrong, yeah, that's the wrong, yeah, 225 actually won't be over here. Okay, so let's just do 45 degrees again. So basically we find that that's 225, so this is 225. I'll just put it like this, 225. But what's this right here? That's 45 degrees also. So basically we know that each one of these are 45 degrees, and then respectively you just put their signs. So so we have sine squared of 45 degrees plus 3 cosine. Now I'm going to put some parentheses, and maybe I should put a big parenthesis. And then I'm going to put minus cosine of 45 degrees, and then square it. Minus 2, and then that's going to be, actually that's positive because it's in the third quadrant. Okay, so let's go ahead and substitute into this equation. So we have, yeah, this is equal to, well, sine of 45 is 1 over root 2, which is the same thing as root 2 over 2, and that's going to be squared, plus 3 times minus root 2 over 2, and that's going to be squared, minus 2 times, well, tangent of 45 degrees is 1, so that's going to be opposite over adjacent, and that's just 1. Now this gives me 2 over 4 plus 3 times 2 over 4, and then this is going to be minus 2, and I already see the answer. Okay, so this gives me, well, this gives me 2 over 4 plus 6 over 4 minus 2, which is equal to 8 over 4 minus 2, which is 2 minus 2, which is equal to 0. So the answer is 0. Now, of course, if you plug this into your calculator, you would have gotten the same exact thing. But it's good to see the algebra that happened. Now, if we go ahead and we look at just one last example relative to like evaluating functions, we can do that. So let's say that we have that we want to try cotangent of negative 930. Okay, so here we're going to put tangent of 930, and we're just going to go ahead and just figure out like how many times do we need to do that. So divided by 360. So we need to subtract or add 360 to 3 times. So 930 plus 3 times 360. And then we just add that. That gives us 150. So I already found that that's going to be negative 930 equals to 3 times 360 and then plus 150 degrees. So the coterminal angle is 150. So let's just do this algebraically, like where you're like, okay, well, cotangent of negative 930 is equal to cotangent of 150. Now, so far, we haven't really done anything. Now, the next thing that we have to do is find the reference angle. So 150, that's terminating in the second quadrant, actually. So it's terminating in the second quadrant, and you have that this is going to be 150, which means that the reference angle is 30 degrees. Now, where did that terminate, though? It terminated in quadrant 2, so all students take calculus. So that's going to be negative. So that's going to be equal to negative cotangent of 30 degrees. Okay, this doesn't look too bad. Now, cotangent of 30 degrees, however, is where you would have that it's adjacent over opposite. So let me... Okay, so good. It didn't do that thing where... Okay, so 1 root 3 and 2. So remember that this is going to be 30 degrees. So adjacent over opposite, that's going to be negative root 3. So that's negative root 3. Now, if you go to your calculator, note that you get the exact same thing. So like you would have to do 1 divided by tangent, not that one. Now, let me just disregard that. 1 divided by tangent of, what was that, negative 930? Yeah. And we hit enter. Now check this out. Minus root 3. It's the exact same thing. So we see that, yeah, if we go ahead and plug it in, we get the approximation right away, but notice that we got the exact value, which is very important. Now, I'll go ahead and leave you with, and this evaluating part, I'll leave you with, like, try sine of 585, and that'll get you going on, what you want to do with this one. So that one's definitely larger than 360, so you need to subtract 360 the appropriate number of times, and then find the coterminal angle. Now, let's say that we want to work in reverse. Now, let's go ahead and consider the following expression. Sine theta equals to 1/2. Okay, so that's kind of interesting. Well, the fact that here we don't really know what theta is, it becomes somewhat interesting because we have that theta can be anywhere between 0 and 360 degrees. But think of it like this. Which one gave us 1/2 for sine? Okay, so which one gave us 1/2 for our sine function? Let's just leave it like that. So we have 1, we have root 3, and then we have 2. Now, remember that the definition of sine is opposite over hypotenuse, which means that the opposite was 1, the hypotenuse was 2. So in that case, that meant that the angle measure was 30 degrees. Furthermore, think of it like this. Where is sine positive? Sine is positive in the first quadrant and the second quadrant. So you have that there's one right here, and then you have that there's another right there. So we have that there's two angle measures, of which gives us the exact same thing. You have that there's that one. Now, in this case, we know that the reference angle was 30. So knowing that this is 180, that means that this is 150. So you have theta is equal to 30 degrees, comma, 150 degrees. Now, if we didn't really specify a number of rotations, in this case 1, we would have actually indicated a general solution, which in this case would have been like 30 plus n pi, or I'm sorry, 30 degrees plus 360 times n, and then 150 plus 360 times n. Now, let's say that we go ahead and we try the following example. Let's say that we try to solve cosine theta equals to negative 1/2. Okay, now since I already well, let's just do it again. I was going to say, like, since I already have the triangle written down, like, we can do that, but, you know, it helps to draw it every so often. That way you don't forget it. Keep getting a acute, or, yeah, I keep getting one of those triangles. Okay, so this is 1, this is root 3, and this is 2. Angles, respectively, are 30, and that's going to be 60. Now, let's go ahead and specify that this is going to be where theta is between 0 and 360 degrees. Now, notice that cosine is negative 1/2. Now, I'm going to do this differently. I'm going to say that I know that cosine is positive in the first and the fourth quadrant, so by that process, I know that it's in quadrant 2, and I also know that it's in quadrant 3. Yeah, so we'll just draw like that. Okay, so we know that the first one is right there, and then we know that the second one is right there. Now, that means that theta has to be relative to 1 and 2, so that's going to be the adjacent and the hypotenuse, and see it like how that's 60 degrees. So that means that you take 180 minus 60, and you're going to get 120 degrees. The other one is that you take 180 and you add 60, and you get 240 degrees, which means that basically you have that the theta value is equal to 120 degrees, comma, 240 degrees, and then that's it. Okay, now in the previous section, I think that you did use the first quadrant, but you know, you didn't really use it that much for the inverse function. So like if you do like cosine inverse of negative 1/2, it does give you the value 120, but notice that it didn't give us the other one, the 240, and that's just because it doesn't account for the angle. So from there, I guess like you could find 120, and then from there just do the 60 takeaway, or 120 minus 180 minus 20, 120, which will give you 60, and then now you know that you have to add to that. So 180 plus 60 is 240, but that's too much at that point. So yeah, like maybe you just want to find like a way that kind of works for you. Okay, now I'll go ahead and end this video with giving you the question that you want to try tangent theta equals to negative root 3 over 3. Or if you want to give yourself like another option, you can do like sine theta equals to negative root 3 over 2. Now, of course, I want you to go ahead and just use that theta is between 0 and 360. But go ahead and start thinking of those things like about what if there was no rotation? Or for this matter, I mean, not no rotations, but no specific number of rotations. But like, what if this was like 720? Then you would have to account for the multiple rotations at that point. Okay. I think that's going to be it for this one. So you just want to practice finding reference angles, and then maybe like even using your calculator for some of them. Yeah, because we could have found some others, like if we wanted to use the inverse function. But do go ahead and use like the other functions as well, like when you're practicing figuring out like the non-acute angles. Okay.